right, today's geometry lesson is going to take you back in time to some things you'll remember from Algebra 1. We're going to start by talking about slopes of lines. So the slope formula, as you will recall, is m equals y2 minus y1 divided by x2 minus x1. That's when you're given 2 points that have coordinates x1, y1, and x2, y2. Remember, every point has an x and a y. The x comes first and the y comes second. And we're just calling one of them our first point and the other one our second point, which are what the ones and the twos represent. So let's see if we can find the slope of some lines, which describes basically how slanted the line is from a couple of given points. So for number 2, here's our 2 points. We're going to start by labeling them x1, y1, x2, y2. We always label the points the same way. And now we're going to put them into that slope formula. So m, which is our slope, tells us how the line moves, is y2, which we have -5 for our y2, minus, remember the minus is in the formula, y1, which is -3, divided by x2, which is 3, minus, again, that's in the formula, -2. And now we're going to do the math. Remember, minus negative means plus. So this actually means -5 plus 3 divided by 3 plus 2. Since these are opposite signs, we subtract and take the sign of the larger number. So that's a -2 on top. And then 3 and 2 more gives us 5 on the bottom. So our slope has a rise of -2 and a run of 5. All right, now we're going to move on and try this one. And I'm going to go ahead and write this formula up here so you can follow along. y2 minus y1 over x2 minus x1. Okay, so we start with our first step, which is labeling the points. x1, y1, x2, y2. Then we're going to put those points into the formula. So start with our y2, that's 3, minus our y1, -2, divided by our x2, which is -6, minus our x1, which is 1. So the numerator is 3 minus -2, which means 3 plus 2. Minus negative means plus, so that's 5. And then -6 minus 1, those are both negative, so we combine those to get -7. It's like -6 plus -1. So -5/7 is the slope of the line that contains those 2 points. All right, I want to recommend that you pause your video and that you try number 6 on your own to see if you can get it, then restart the video to see if you got it right. Okay, so hopefully you labeled them x1, y1, x2, y2, put the numbers in the formula. y2 is -3, minus y1 is 10, divided by x2 is -4, minus x1 is -2. So in the numerator, -3 minus 10 is -13. And in the denominator, -4 plus 2 is -2. Now, negative divided by negative is positive, so this is the same thing as 13/2, which is a fine answer. Or if you actually divided it and gave me the decimal equivalent, that's fine too. I would just leave it as a fraction in dealing with slope. That's probably my preferred way to leave the answer. Okay, the next section gives us pictures of lines and tells us to find the slope of each line. So the first one is line AB. You can see this point down here is A at -2, -2. The origin is where the 0 is, right here in the middle. And then point B is up here with coordinate 0, 4. So what we're doing, you could use the same slope formula that we used for the first set of problems, but on these you can actually just do it by calculating the rise over the run. So start with whichever point is further to the left of your graph, and then count how much do you rise and how much do you run to get to the other point that's marked on the line. So from A, I'm going to count jumps. Every time I jump up a line, I count another number. So this is 1, 2, 3, 4, 5, 6 jumps up, and 1, 2 jumps to the right. So my rise is 6, and my run is 2. And it's division, 6 divided by 2 equals 3. So that has a slope of 3, which means like rise 3, run 1, because a 3 over 1 is what we're looking at here. Okay, number 9. From E to M. So E and M are on a vertical line. So from point E, I go up 1, 2, 3, 4. So the rise is 4. But the run, it doesn't run at all. It doesn't go sideways at all. So the run is 0. And 4 divided by 0, you will remember from algebra, is equal to an undefined number. There is no number that you can multiply times 0 and come up with 4 as the answer, because 0 times anything is 0. So if you were to type that in a calculator and press enter, it would give you an error message. So you are just looking at an undefined slope here. Any vertical line is going to have an undefined slope too. So if you just recognize that and remember it, you don't even have to count rise and run. Okay, for number 10, AE. We're looking from A over here on the left to E over here on the right. This is a horizontal line. So from A to E, my rise is 0. And my run from A to E is jump 1, 2, 3, 4, 5, 6 times. 0 divided by 6 is equal to 0, okay? Horizontal lines have a slope of 0, because if you multiply 0 times 6, you get 0. So if you will remember that every time you see a horizontal line, the slope is 0, you don't actually have to count the rise and the run. But if you type 0 divided by 6 in your calculator, it will give you 0 as your answer, okay? All right, the last one here is the line from point B to point M, okay? So point B is up here at 0, 4, and point M is over here at 4, 2. So I recommend that you pause the video and see if you can determine that slope on your own, then play it back and see if you got it right. So the rise from point B to point M is actually not a rise at all. It's going down 2. Instead of rising up, we're going down 2. So that's a negative 2 for our rise. And then the run is over 1, 2, 3, 4 units to the right. Okay, and that fraction can be simplified because the numerator and the denominator are each divisible by 2. So if I divide the numerator by 2, negative 2 divided by 2 is negative 1. And the denominator divided by 2, 4 divided by 2 is 2. So that simplifies to negative 1/2 for the slope. Hopefully you got that one right. All right, we're going to go on and take a look at a couple of problems over here on the back that say determine whether line MN and line RS are parallel, perpendicular, or neither. Graph each line to verify your answer, okay? So you may need some graph paper to do this. You can get free graph paper online if you're working from home and you don't have actual graph paper, or you can just make a sketch, you know, as long as you try to draw it fairly accurately, that should be okay. But what you'll remember from algebra is that parallel lines have the same slope. So whatever the rise and the run are for one, they will be the same rise and run on the other. Now, perpendicular lines have opposite reciprocal slopes. So that means, like, if I had one slope of 3/2, that would be perpendicular, which is the upside down capital T symbol, to the slope -2/3. So you flip the numerator and the denominator upside down and change from positive to negative or negative to positive. That means you've got perpendicular slopes. Both of those things have to happen. If anything else happens, the answer is neither. So they give us the coordinates of 4 points, 2 for the line MN and 2 for the line RS. And we have to figure out, are these lines parallel, perpendicular, or neither? Okay, so I'm going to get out my little sheet of graph paper and I'm going to look at these points. Looks like the biggest number here is 8. So I just need to make sure that my graph is big enough to go out 8. And I'm going to make a little graph. Maybe right here. Okay, so I'm going to start by plotting my point M, which is at 0, 3. My point N is at 2, 4. Remember, this is my x-axis and this is my y-axis. The x number in the point is what goes first, and then the y number in the point is what goes second. So there's my line MN. It's going to go through those 2 points. I could go ahead and make it now. Try to make it as straight and accurate as I can. Woo! I hit my little camera here. All right, there's my line MN. Now I'm going to plot my line RS. R is at 2, 1. So over 2, up 1, there's point R. And point S is at 8, 4. So I'm going to count 1, 2, 3, 4, 5, 6, 7, 8 to the right. And 1, 2, 3, 4 up. There's point S. So I've got my other line ready to rock and roll now. Okay, so now if you were to just eyeball these 2 lines, what do you think? Do they look parallel, perpendicular, or neither? Do they look like they have the same slope, opposite reciprocal slopes, or neither of those? Well, we can figure that out by looking for the rise and the run on the graph that we made, since they told us we had to make a graph. Or you could use that same slope formula, y2 minus y1 over x2 minus x1. So there's more than one way to arrive at the answer to this problem. And as long as your way, you're showing your work and, you know, using the rules of geometry and algebra, then great. So I'm going to look for the rise and the run. From M to N, I count up 1 to the right 2. So the rise is 1 and the run is 2. Okay? Now I'm going to look at the rise over run for RS. I go up 1, 2, 3. So the rise is 3, and the run is 1, 2, 3, 4, 5, 6. Well, that's not the same thing as 1/2, but guess what? This fraction is not simplified, and if you simplify it, both the numerator and the denominator are divisible by 3. So if I take 3 divided by 3, that's 1, and 6 divided by 3 is 2. So this one actually also has a slope of 1/2. They are the same slope. I'm going to put the little parallel line symbols on these lines, and the answer is that these are parallel. Okay? Now, number 2, the next one we're going to do, has, let me come back over here. We'll write, this was parallel. Did it on graph paper. Now the next one has these given points. M at -1, 3, N at 0, 5, R at 2, 1, and S at 6, -1. So we need to plot those on the graph. My biggest number is 6, so I just need to make sure that it's big enough to go out to a 6. And I'm going to make my little graph, X and Y axis. Ooh, that pen is super inky. It's leaving blobs. Okay. So now we're gonna plot. M is at 0 sideways and then -3 for the Y. So that's point M. Oh wait, I apologize. I was looking at the wrong problem. -1 for the X and 3 for the Y. 1, 2, 3. So here's my M. This is a mistake. We never make mistakes in math class. Ha ha ha. Yes, we do. Okay. N is at 0 for X and 5 for Y. 1, 2, 3, 4, 5. There's point N. So there's my line from M to N. Try to get that real good and lined up. All right. There's the line at MN. Now we're gonna do the line RS. R is at 2, 1. And S is at 6. 1, 2, 3, 4, 5, 6, -1. Okay. There we go. Okay, so do they look like they're parallel? I don't think so. Parallel lines do not intersect, and these have an intersection point. It's hard to tell what that intersection point is. It doesn't look like it came out to a nice number there. But let's determine what the slope of each line is. We're going to do this graphically again with the rise and the run. So from M to N, I rise 1, 2, and run 1. So rise 2, run 1. From R to S, I don't go up to get from R to S. I go down. So down 1, 2 is a rise of -2. And then the run is 1, 2, 3, 4. Okay, that fraction is not simplified because 2 goes into both of these values in the numerator and the denominator. -2 divided by 2 is -1, and 4 divided by 2 is 2. So let's compare these slopes. 2 over 1, 1 over 2. Do you see how they flipped? That's called the reciprocal. This one's positive and this one is negative. So they are opposite reciprocal slopes, which means they are perpendicular. This is a 90-degree angle here. Perpendicular. Okay, so for this problem, perpendicular. I did that on graph paper. Okay, the next problem says graph the line that satisfies each condition. It has a slope of 4 and it passes through the point 6, 2. You're going to start with whichever point they give you. So 6, 2, 6 is the X, so from the origin I'm going to count 1, 2, 3, 4, 5, 6 units to the right. Then the Y is 2, so up 2. Okay, this is the point. And the slope is 4. Now slope is rise over run. If they only give you one number, you put a 1 underneath it to make it a fraction. That's super important. You need 2 values for your slope, even if one of them is a 0. But in the case that you just have an integer value for your slope, put a 1 underneath it to make it a fraction, because 4 divided by 1 equals 4. That's the same value. So we're going to count from this given point, rise 1, 2, 3, 4, run 1 to the right. And that's all we need to make our line. And we'll put arrows on the end because lines go on forever. And that one is done. Okay. The next page has equations of lines, which you also learned in Algebra 1. You probably used slope-intercept form, which is y equals mx plus b the most, but you probably also learned about point-slope form of a line, the y minus y1 equals m times x minus x1 form, okay? So m is the slope in both equations. In the top one, b is the y-intercept, which is where the line crosses the y-axis. And in the second equation, it has an x1, y1, which is any point on the line. So that will work no matter what point they give you, okay? So let's go down here and see what we can do with this. The directions say, write an equation in slope-intercept form. So slope-intercept form, they're telling us which form. We're going to use y equals mx plus b. Remember, m is your slope, and b is the y-intercept. Okay, so write that for the line having the given slope and y-intercept or given points. Then graph the line. Okay, so we are going to focus here on writing the equations because we just did an example with graphing on the previous page. So my first equation, it's going to be y equals the number in front of the x, remember, is your slope, your m, so that's 2x. And then plus b, you could put plus -3 or you can just put -3. Either one is fine. I would take it either way. That's that one done. On number 2, it says the slope is -1/2 and the y-intercept is 4. So y equals -1/2 times x, the slope goes in front of the x as its coefficient, plus 4 for the y-intercept. Okay, why don't you pause the video and try number 4 on your own, and then you can check and see if you got it right. Okay, so y is equal to 0 times x plus -2 or just -2. Now, 0 times anything is 0, so you might have also simplified this to y equals -2, which is a more simplified answer, and probably the one that I would prefer. However, this one is also correct. So hopefully you got that right. Okay, the next one, the directions say write an equation in point-slope form this time for the line having the given slope and the given point. So that's going to be y minus y1 equals m times x minus x1. So they give you an m in each problem, and they give you a point. You label the point x1, y1, and then you fill those values into the formula. So this first one is y minus my y1, which is -1, equals m, which is 1/2, times, in parentheses, x minus 3. Now, you might have also changed y minus -1 to y plus 1 because that means the same thing and is probably more simplified, so that would be great if you did that. But this is also correct and fine to leave it like this. Okay, let's look at number 8. The slope is -2, and here's our point for -2. We're going to say x1 is 4 and y1 is -2. And put the values into the formula. So y minus y1, which is -2. I could put -2 or I could put +2 Minus -2 means the same thing as +2. So I would take that either way. Equals -2 times x minus 4. So that's the answer. All right, number 9, m equals -1, and then the parentheses, the point has x1, y1 as -1, 3. Why don't you pause your video and try this one on your own and see how it goes? Okay, hopefully you got y minus 3 equals -1 times x minus -1, or you could change that minus negative to a plus like I did on number 8 with the y minus -2. Okay, either way, I'll take it either way. All right. Are you having flashbacks to Algebra 1? Are you ready for a word problem? Of course you are. Okay. Use the following information. Jerry's current satellite television service charges a flat rate of $34.95 per month for the basic channels. So just to get the basic channels, you have to pay that amount, okay? And, remember the word and in math often means plus. An additional $10 per month, $10 per month for each premium channel. So whichever extra special channels they want, they tack on an extra $10 per month for those, each one. A competing satellite television service charges a flat rate of $39.99 per month for the basic channels and an additional $8 per month for each premium channel. So notice the first company charges less for the regular monthly fee. The second one charges a little bit more for the regular monthly fee, but the first one charges more for each premium channel than the second one, $2 per premium channel more. So the first problem here, it says write an equation in slope-intercept form that models the total monthly cost. So we're not worrying about the year, we're just worrying about what we pay each month for each satellite service where P is the number of premium channels. So we're writing an equation for the cost. So I'm going to put C equals. Normally we go y equals mx plus b when we're writing slope-intercept form. But I'm going to do C equals MP plus B, because P is going to be the variable they want me to use for the number of premium channels. So we're going to take, for the first company, $10 for each premium channel. So it's going to be 10 times the number of premium channels that we have. And we're going to add that to the monthly fee of $34.95. Okay, that's for the first company. The second company costs $8 for each premium channel. So P is the number of premium channels. We multiply those. And we add that to the $39.99 cost that they charged us for the basic channels. Okay, so there's our two slope-intercept form equations, one for each company. Next, number 2 says, if Jerry wants to include 3 premium channels in her package, which service would be less, her current service or the competing service? So the current one is the one that she has up here at the top, current satellite television service. So this is the first equation, okay? So we're saying for 3 premium channels, which one is going to be the better deal? So the cost for her current company will be 10 times 3, that's 30 of course, plus $34.95. So what does that add up to? It's going to cost $64.95. Now, The other company, the competing service, charges $8. And we're saying 3 premium channels. So that's going to be 24 plus $39.99, the monthly fee. So that comes out to $63.99. So which service is less? The competing service is less. Okay, hopefully you had a good time going down memory lane to look at some of this algebra stuff you've learned before with slopes and equations of lines. I hope your homework goes really well. And of course, if you have any questions, please reach out and let me know how I can help you. Have an awesome day. Bye-bye.